When working with sequences, it is often beneficial to see how the terms of that sequence behave. If we think about a sequence as a succession of numbers, then we can plot those numbers on the number line and observe the behavior. So for example, if I have a sequence 1, 1/2, 1/4, 1/8 and so on, we can plot those numbers, those terms on the number line. First term is 1, the second term is 1/2, then third term is 1/4, then the fourth term will be 1/8, which is half of 1/4, and next term we know it's going to be 1/16, a half of 1/8, and then half of that is going to be 1 over 32, and so on. So once we have those points plotted, it is easily seen that the values in that sequence are decreasing, they are getting smaller and smaller, they are positive, and they are approaching 0. Now, if in turn we are thinking about a sequence as a function, we can graph this function in the coordinate plane. And we can make the table that will have the values of x, which this time are values of n, and the values of y are going to be the values of the sequence. So x is equal n and y is a sub n. The values of n are 1, 2, 3, 4, and so on. These are the values, the inputs, and the values of y are values of a sub n. So the first term is 1, the second is 1/2, the third is 1/4, the fourth is 1/8, and the fifth will be 1 over 16, and so on. So plotting those points in the coordinate system will get point 1 and 1, point 2 and 1/2, point 3 and 1/4, point 4 and 1/8, point 5 and 1 over 16, and so on. So as you can see, we have a graph. Now it is not the graph as we used to see, where once we plot the points we connect it with the continuous line. Here we cannot do that because the domain contains only points 1, 2, 3, 4, and so on. So there is no graph for x equal, for example, 1/2. There is no point on the graph. So the graph of a sequence is just the set of the points as it is drawn. And looking at the behavior, if we are interested, you can notice that those points are approaching the x-axis.